Hello, welcome to my YouTube channel. This time I'm going to share with you a project that I did with an STM32F030, which I call the backdoor programming of the microcontroller. I use the Blue Pill microcontroller programming from ldmicro. So without wasting time, let's go and I'll show you what I did. Okay, to start with, you get this board from an inverter, the mast inverter. I got it from the mast PV1800 model of the inverter, and inside there is a board, a communication board, and this board has got a STM32F030 chip, which actually does the USB to RS-232 conversion. But on this board there was actually an RS-485 chip, the STM35176 IC. So I took that one out and I placed the logic gate for the watt interface to the programming interface. So this is the ldmicro program that I wrote for the solar charge controller. It's just a basic solar charge controller design that I normally do, and I'll share with you this design. This design is very simple to do, and it's the basic design for most charge controllers, and it's a pulse width modulation type. Right, as you can see here, this is the code I'll give to you. This is going to be shared in full. Okay, the X code, the ldmicro code. As you can see also, it has got this meter for the battery voltage, which indicates the state of charge. Right, this is what ldmicro produces. This is the C file that ldmicro produces, and you have to adjust this file. The adjustment of this file is because when you compile the C code, cube IDE, the cube IDE won't be able to read the code, so you have to adjust to suit the IDE. Right, this is the board that you get from the inverter. Okay, I thought maybe we should start discussing this one. On this Max 232 there is the 485 transceiver, which is a differential transceiver that is on the board. You have to take out that Max 232 design there and put the logic gate. So the design will actually be looking something like that. Okay, you can use transistors to actually do the conversion, because the UART signals are actually a conversion of the original transmitted signals. So you need an inverter, an inverting circuit. So we are transmitting 5 volts and 0 volts actually, and that we should do for a programmer. So this is what I did with my programmer. Okay, and it's a simple circuit. And then after the D9 connector, you have to put an adapter for programming, as I have actually indicated or shown you in the previous projects. So this circuit is easy to construct. You just take the board, you replace the STM35176 IC, and then you either put a logic gate or you put transistors there. Right, this is the programmer that I built. Here is the USB connector, and here is the board from the inverter, which are actually enclosed in a tape, right? And you can see the programmer in full. These are the pictures of the programmer. Okay, and this is the simple interface to the microcontroller now. That actually does the link from the programmer to the microcontroller, and it's a simple circuit also, as I have actually shown you in the previous project. So it's an easy programmer, simple transistors, diodes, and resistors in there. Okay, right. Here also you can see the pictures of the programmer. Okay. Now here is the Cube IDE, and you can see the successful compiling of the file, and you actually copy the C that the ldmicro produces, adjust it, and then you compile. I'll show you how you can adjust it, and I'll actually share with you the whole code. And then here is the cubemx configuration that you do, and you can see there the IC and its pinout naming and actually configurations, right? The timing here, I had an issue with the timing of the IC, the clock configuration. Yeah, it only was accepting around 4 megahertz. Actually, it wanted 3,6, if I'm sure. It didn't want any other higher clock speed. I don't know where I was going wrong. Maybe someone who actually give me a feedback of where I was going wrong. Only issue that I noticed was the versions of the Cube IDE and the MX version. They were not really compatible. It was asking for a later version. The IDE was a bit higher than the MX, the configurator, so it needed a later version of the configurator. Maybe that's where it was coming from, but I failed to actually have a good timing clocking speed. So, but anyway, the project actually was a success. These are the settings that I did, and this is what the programmer will actually produce using the Cube programmer. And you can see the chip there being identified, right? It works wonders, and it looks ugly, but it does the job. Okay, so coming to the code there, you see there is the C that the C code that you have to adjust. Okay, so I'll show you where you need to adjust. Okay, right. So the ladder file, you have to actually adjust the okay, you actually comment out all those the libraries for the blue pill that ldmicro actually produces, because you are actually using a 030 rather than a 103 microcontroller. And then also the tab definitions there, you have to change the tab definitions there. You see the difference there. Okay, that is the adjustment that you have to make to the ladder file that the ldmicro produces, right? Now there is also the adjustment that you have to do to the C file. I'll show you. Okay, this is the analog to digital converter. You can see that ldmicro produces that one, you have to change that one, adjust that one to what I've shown there. Okay, and also you have to remove the configurations from the ldmicro file and replace, because cubemx will actually do that for you, right? And then we'll just go around quickly as possible. Please copy the PLC cycle part there, you must remember, and paste it into the while loop. Okay, PLC cycle into the while loop, don't forget that, because that's the whole core of the code, right? I think that's more about it. Now we are going to show you the project that I did. Okay, now this is the solar charge controller that I've made with an STM32F030. Okay, and that one is the programmer. This one here, that's the programmer of that chip here. Okay, that's the chip, the STM32F, and then the front LEDs cycling. Okay, showing yellow now, it's on absorption stage, and the LEDs are indicating the state of charge. Okay, right, and that's the power module. Okay, right, okay, battery negative there, and the solar negative side switch there. Okay, it's charging. Okay, right, and it's regulating at 14.48. okay, 14.5 volts. Right, just a bit. Okay, and that's the battery charging, and I'm using that power supply. Okay, that's the power supply I'm using. Okay, you can see the voltage there. You can see, right, that's the voltage. Okay, right.